Since the beginning of time, people have been lending tools and other possessions to people, and on occasion have asked for compensation for this service. This compensation is called rent, the price of borrowing someone else's property. Money is also often loaned or rented for its purchasing power, what that money can buy. The rental price of money is called the interest rate. The interest rate is the price of borrowing money for the use of that purchasing power. In this chapter, we'll look at interest rate quotes, how to apply interest rates to discount rates and loans, what goes into making an interest rate, why are interest rates high or low, and right now, very, very low, and what is the opportunity cost of capital. The objectives of this section on interest rates is to look at how interest rates are quoted. Use those quoted rates to calculate loan payments. And this is something of importance to everybody. If you are ever going to have a car loan or a mortgage, you want to know how these loan payments are made and what interest rate you're really paying. And it's not necessarily what the bank says you're paying. We also need to look at how inflation enters into what interest rates are and what other factors determine interest rates. And look at the link between market interest rates and what a firm has to pay for the cost of capital. Let's look at interest rate quotes. This is the price of money. And as I said a few minutes earlier, that price of money may not be whatever the bank tells you it is. We're going to relate this to the opportunity cost of capital. What else could you be doing with the money, you as an individual or with the company? What's the best available expected return that's offered in the market on an investment of comparable risk and term, number of years, to the cash flow that's being discounted? So the opportunity cost, basically you're answering the question, what else could you be doing with the money? Let's look at how interest rates are quoted. If you go to a bank, the bank is only required by law to quote the annual percentage rate, what the rate is on a yearly basis with no compounding. And that's great if the time period is 1 year. The effective annual rate and the annual percentage rate are the same. APR and EAR are the same if we're talking about an annual time period. And let's look a little bit at that. We've got $100. Let's say the rate is 5%. After 1 year, $100 is going to grow to $105. After 2 years, it's going to grow to 100 times 1.05 times 1.05, or $110.25. So that's fine if you're talking about a year's period. But if you're talking about a period of less than a year, your money's going to grow faster. So that's a good thing if you're the one saving or investing the money. But if you're paying a loan, and typically mortgage loans are monthly, car loans are monthly, you're actually paying more than whatever the stated interest rate. And that's fine. You just have to understand that you are paying more. Now, what we can do is adjust the discount rate to different time periods. So let's say we're talking about an equivalent annual rate for a longer time period. Well, if I take the square root of 1 plus r, the square root of 1.05, that's 1.0247. So I would be getting, if I'm getting cash flows on a semi-annual basis twice a year, and my annual rate, my EAR, is 5%, that is the same as getting 2.47% for every 6-month period. So the point is the equivalent annual return is greater than the interest rate over each period. If I add up 2.47% plus 2.47%, that's going to be slightly less than 5%. So I am getting a lower rate over each of those 6-month periods to make up a 5% annual rate. So what that is saying is, if the compounding is more frequent than annual, and in this case semi-annual, I need a little bit less. Instead of 2.5%, I need a little bit less, 2.47%, because of compounding in order to get that 5% by the end of the year. Let's look at how we can turn an interest rate into a periodic interest rate. An interest rate for a period. The period could be a day, a month, a quarter, 6 months, semi-annual, whatever time period we need to use. The general formula is that 1 plus the periodic interest rate raised to the nth power, and n is the number of periods, minus 1 tells you that equivalent interest rate. So in other words, if I have a 12-month loan, n is going to be 12, and I'll take that periodic interest rate raised to the nth power minus 1. So let's give an example. Suppose you have a 1% monthly interest rate. You're paying 1% per month on a loan. Well, 1.01 raised to the 12th power minus 1, that is going to be more than 12%. So if I'm paying, I'm really paying more than 12%. If I'm receiving, great, I'm going to be getting more than 12%, and I'm certainly happy about that. Banks are required to quote annual percentage rates. The interest rate per compounding period is very simple. Whatever that quoted rate is divided by the number of compounding periods. And we've got the interest rate per compounding period. So if we put this together, we look at the equivalent annual return. What are we really paying or really receiving? We're going to use this formula. 1 plus the equivalent annual return is equal to 1 plus the APR, or the nominal rate, or the non-compounded rate, divided by the number of compounding periods raised to that power.